So I'm continuing on my journey to doing the previous AIMO questions. I think this might be 2015. I have to check, but yeah, actually I didn't read the instructions carefully last time. I didn't realize that so you have 4 hours, and the first 8 questions you only need to write the answer, so you don't even have to justify or the proof. So sometimes that'll be quite useful if you're very sure, but your argument is clumsy. And no calculators, so which is good because I wasn't using a calculator anyway. Okay, so I look at this exam, and I guess I want to just sort of eliminate the easy questions first. So, for example, the first one looks pretty easy. The third one, the fourth one, the fifth one took a little bit of effort, but I think it's still quite easy. And then the 8th one. Okay, and so you could probably do all this in like maybe 20 or 30 minutes. Most of it's just writing things out. If you're quick, you could probably do it in 10 minutes. And the marks are roughly, so 4 marks. 4 marks, 7, 10 marks, 13, 15. So 15 out of the possible, how many marks are there? And so the bonus mark, it doesn't seem to count as a bonus unless you lose marks. I'm not sure. Okay, so there's 10 marks over there. 12 is 22, 25, 31, 35. So it seems to be 35 marks possible. 2 bonus marks. Okay, so what we just did was we did the 10, 13, 15 out of 35. It's like, it's not really it's like half. There's not, certainly much less than half the difficulty, but close to half the mark. So 3/7. Yeah, so let's go through them quickly. The number written base A is 123. The number written base B is 146. What is the minimum value of A plus B? So already you can see there's not that many choices, so like brute force should solve this problem, but so hopefully you can reduce the amount of brute force you need. So for example, when you see 6 here, the base has to be bigger than 6. Assuming everything makes sense, and the bases are between, I guess they're between, just assuming it's between 2 and 9, but it could be maybe base 10 or 11 or something, but that would just make the notation very strange. So there's some implicit assumptions on what a base means, which is actually kind of interesting. Yeah, so if you try, try base 7. So if you try base 7, 146 means 6 plus 28 plus 49. So 6 plus 28 plus 49. And that is equal to a 93. Is it? $87. No, sorry. Yeah, I mean 83. So this is 60, 77, 83. Okay. And you know, if this number is smaller in this base, then the base should be bigger. Okay, because if the base was smaller, then the number would look even bigger. So try 8 for A. So if A was base 8, this would be 3 plus 16 plus 64. Okay, notice that's also 83. So this appears to be the minimum. So the minimum should be 15. Okay, so I guess I'm not really sure if 2 is easy or not. I just skipped it because I had to draw a diagram and I can't really fit that here. So these are meant to be all questions I can do like in the space on the question sheet. 3 is like super easy. Well, it doesn't mean you'll get it right, but it doesn't mean I'll get it right. So you know, 3 something plus 7 something else plus 1 something else costs this. 4, 10, and 1 cost that. What is the total cost of 1, 1, 1? Okay. So that's kind of, you know, you might not see the answer straight away, but you can see here you can play around with things straight away. So if you have like this is x and this is y, you can subtract x from y to get 1, 3, 0. Okay, so 1, 3, 0. And the costs will subtract. So 329 from 441. Okay, but then 130, if you track 3 lots of that from this, you'll get, you know, 3 lots of this is 390. So 390 from this will get 111. So if you subtract 3 lots of that from this, you'll get the answer you need. So you just got to do that with the money. So subtract 329 from 441, times it by 3, and then subtract that from 441. Okay. Number 4. Maybe should I do that? I mean 441 minus 329 times 3. So 441 minus 3 times that. So that'll equal to 3 times 329 minus 2 times 441. Which is, you know, this is like, there's lots of ways to do this. So, you know, 987 minus 882. So 105. One 5, 15. Okay, so I think I did this one next. Yeah, I think I could do this one without even writing it down. But so a over b is in simplest forms, which means they don't have any common factors. Is written in the form 2 on n plus 1 on n squared, when n is a positive integer. A plus b is 1024. Yeah, so 1024 is 2 to the power of 10, which is 32 squared. And so I rearranged everything so that there's no fractions. So you get an squared equals b times 2n plus 1. And I think from here you can even deduce that b is equal to n squared and 2n plus 1 is equal to a. Because because b divides this and has no common factor with a, so it must divide n squared. Okay. And 2n plus 1 has no common factors with n. So it must divide a. So actually b is equal to a n squared and a is equal to 2n plus 1. So a plus b is n plus 1 squared, which is 32 squared. So n plus 1 is 32. So n is 31. So since a must be 2n plus 1, a is 63. Okay. And I guess it's about as quick as it goes. Oh, okay, so this one, I felt a little bit annoyed at first when I did this, because I felt like I had to use my brain a bit too much. But then, once I did, well, I realized I didn't have to use it too much. So basically, what I tried to do was, I worked out what 2 to the 13 plus 2 to the 10 was, which is like 9,000 something, and tried to add powers of 2 until it made it a square. So I kind of did it a bit backwards by finding what the squares are that are in the vicinity, like 100 squared is 10k, and then tried to see if the difference was a power of 2. And then I realized that, I just squared a bunch of things. So I got a bit annoyed. I squared more than 6 things. I guess I'm just kind of losing patience. But once I squared enough things, you realize that you weren't gonna get a square number by adding something with 2 to the power of 10 or less. Okay, so you're gonna need x at least 10. And if that's the case, then there's a common factor of 2 to the 10 on the left hand side. Okay, and if there's a common factor of 2 to the 10, what's inside is going to be 2 cubed plus 1 plus 1 plus some other power of 2, and that's going to be a perfect square. So the problem is reduced to finding y and x prime, I guess, when you just look at 3 and 0 instead of 13 and 10. And 2 to the power of 3 is 8, and 8 plus 1 is 9. And it's obvious, actually, from just basic Pythagorean triads that 9 plus 16 is a square. So it works. Excuse me for a second. I'll do the other parts in the next one, but I'll be